Okay, so yesterday we started Unit 2 where we talked about remembering what equivalent ratios are and remembering what a double number line is. And I showed you this example of a double number line that compares hippos to crocodiles. Yesterday we said that double number lines start with 0, and we noticed that we don't have to count by the same number on each line, right? So the top is counting by 4s, the bottom is counting by 3s. However, what's important is that the equivalent ratios line up together like these do. So right here we have for every 4 hippos, there is 3 crocodiles. So those two numbers are lined up perfectly, so they go together. If we were to double that and keep that same ratio, we have for every 8 hippos, there are 6 crocodiles. Even though they're different numbers, 4 to 3 and 8 to 6, they are equivalent ratios. And then we talked about how there's 3 different ways to write a ratio. We have that here in red. We can write 4 to 3, 4:3, or as a fraction 4/3 or 4/3. So 4 to 3 for 4 hippos, there are 3 crocodiles, is an equivalent ratio to 8 to 6, because 8 to 6, if we divide the top and bottom by 2, we still get 4 to 3. So there's still 3 alligators for every 4 hippos. Or we could take this top ratio 4/3, multiply the top and bottom by 2, and then we come up with 8/6. So I played this video for you yesterday.
Oh no. Man, it's gonna kill me.
And I asked you how he could fix his recipe, right? So Nana likes her chocolate milk with the right amount of chocolatiness. She has to have 1 cup of milk with every 4 scoops of chocolate. He accidentally added an extra scoop. So a lot of you guys gave really good answers for what we could do. I had you fill out a double number line to help you with the ratios. So as a reminder, when you're filling out the double number lines, you want to start with 0, and then the way I asked you guys to fill it out is figure out which number is bigger, the 4 scoops, the 4, or the 1 over here with the 1 cup of milk. Well, the 4 is bigger, so I choose to label that first. Again, you guys can count by any number you want to count by. I usually try to count by 1s if I can, if there's enough room. So on the bottom number line, we are counting by 1s, but I only labeled every 4th one. So 4, 8, 12, 16, 20, but every line still represents 1 scoop. Then on the top, we had to make sure that the 1 cup of milk lined up with the 4 scoops of chocolate, right? I couldn't have put the 1 on the first line because then that doesn't line up with the 4 on the bottom. So 1 cup of milk for every 4 scoops of chocolate. Then we lined up the 2 with the 8, and so on and so on. Once you have your double number line filled out, we can kind of see what our solution can be. So some of you guys said, well, he can just double his recipe. If you need 1 cup of milk with 4 scoops of chocolate and you double that, then 2 cups of milk will give us 8 scoops of chocolate. And that did seem like a good solution. There were a lot of different solutions. However, in that video, That cup was almost filled up to the top with just that 1 cup of milk. So realistically, we would be unable to fill up that glass with 2 cups of milk. So I asked you to think, well, what else is a realistic solution for this problem? We don't really want to start all over. Yes, some of you guys said grab a different large pitcher and put that in, but we want to try to keep it in that same glass. So, we had to figure out, well, what can he really do? He has 5 scoops of chocolate, right? And some of you guys said add a little bit more milk, but specifically how much milk, right? So with the 5, we have this number here that lines up. I didn't fill that out, but we can figure out how much each one of these lines represents. So if from 0 to 1, that is split up in 4 parts, 1 over 4 is a fourth, or 0.25, however you want to see it. They're both a quarter. So each one of those lines, sorry, I should have put 1.25. 1.25. Each one is 0.25 or a quarter. So this one is a 1.25. This one's 1.5. And that makes that one 1.75 because you're going up 0.25 each time. So we have a few different solutions depending on how many scoops you want in your chocolate milk. So he could, if he wanted to keep the 5 scoops, he would just have to add 0.25 or a quarter more cup of milk. Or he could do 6 scoops of chocolate, but then he would have to add a half a cup of milk. He could have also done 7 total scoops of chocolate, and then he would have to add 0.75 of a cup more. And those are all equal ratios, so those could have all worked. Okay, so he chose to add half a cup of milk more and 2 more scoops of chocolate. And again, that works. That was one of our solutions on our double number line. Here, 6 scoops of chocolate goes with 1.5 cups of milk. Also, if we check, there is a pattern here. Every number on the bottom is 4 times larger than the number on top. So 1.5 multiplied by 4 gives us 6. Suppose you want your chocolate milk to be more chocolatey than Nana's recipe. How could you make Nana's recipe more chocolatey? So remember, hers is 1 cup of milk and 4 scoops of chocolate. Suppose you try it and you're like, no, this is not chocolatey enough. So what would you do to that recipe to make it more chocolatey? So hopefully you chose add more chocolate scoops, right? If you add more milk, that's actually going to make it less chocolatey. So you would have to add more chocolate scoops if you want it to taste more chocolatey. If Nana's recipe for scoops of chocolate to cups of milk is 4 to 1, or we can write it as 4:1, it still reads 4 to 1, which ratio would make Nana's recipe more chocolatey? The flavor depends on both how much chocolate mix and how much milk there is in the mixture. For a given amount of milk, the more chocolate mix you add, the stronger the mixture tastes. Likewise, for a given amount of chocolate mix, the more milk you add, the weaker the mixture tastes. So for this last problem, you had to reduce or simplify each one of these fractions. 8 to 2, if we divide both numbers by 2, we get 4 to 1. So this is the same as 4 to 1. And that's the same as Nana's recipe, so it would taste the same, not more chocolatey. 6 to 2, divide both of those by 2, you get 3 to 1. That is less chocolate. That's only 3 scoops of chocolate with 1 cup of milk. This part C simplifies to 5 to 1. 5 scoops of chocolate with 1 cup of milk. That is more chocolate than her original recipe. So this one looks good. And if we were to, sorry, that's just a 0.5. Divide these two by 2. You get 2.5 scoops of chocolate for every 1 cup of milk. So that is much, much less chocolatey. So you should have chosen C for that one. We can double, triple, half, etc. a recipe without changing the flavor if you keep the same ratio of ingredients. That is, equivalent ratios of ingredients. So recipes taste the same if you keep the same ratio of ingredients. How is Moon D different from the other 3? Okay, so we can use ratios to actually describe how Moon D is different from the others. A, B, and C are scaled copies. D is not. Below here, we have a table that compares the total length of each moon and the total width of each moon. Right, so we have the length and the width. And then in the third column, it shows the ratio of length to width, so length over width for each one of the moons. So C, B, and A, the ones that look more similar, C, B, and A, when we take the length and put it over the width, we'll notice that we get this equivalent ratio, the same fraction for all 3, 2 over 3, 2 over 3, 2 over 3. Right? Even though it's 4 over 6, it simplifies to 2 over 3. However, for Moon D, 6 over 4, right? So they count the length, put it over the width, 6 over 4. That doesn't look like 2 over 3. What ratio is 6 over 4 when you simplify that? When you simplify 6 over 4, you can divide the top and bottom by 2. We get 3 over 2. And 3 over 2 is not the same ratio or same fraction as 2 over 3. Okay, so we have this definition here of equivalent ratios. 2 ratios are equivalent if you can multiply each of the numbers in the first ratio by the same factor to get the numbers in the second ratio. For example, 8 to 6 is equivalent to 4 over 3 because half of 8 is 4 and half of 6 is 3. So 8 over 6 is the same as 4 over 3. So we have an example here. A recipe for lemonade says to use 8 cups of water and 6 lemons. If we use 4 cups of water and 3 lemons, it will make half as much lemonade, but both recipes will taste the same because 8 to 6 and 4 over 3 are equivalent ratios. It's just half. Okay, so we have that same problem here. I want you to type in another pair of numbers that can keep the same taste of lemonade. So you're not changing your recipe, right? You're just changing the size. You're changing how much lemonade you make. Make sure you type in the cups of water number first and then the number of lemons second.